Welcome you all to this session, children. Today's class we are going to read about the third chapter, classification of elements and periodicity in properties. Before going deep into the subject, let us first analyze what is the need to classify elements. At present, 114 elements are known. Of them, the recently discovered elements are man-made. Efforts to synthesize new elements are continuing. With such a large number of elements, it is very difficult to study individually the chemistry of all these elements and their properties. To ease out this problem, scientists searched for a systematic way to organize their knowledge by classifying the elements. Not only that, it would rationalize known chemical facts about the elements, but even predict new ones for understanding further study. So, let us have an idea about the early attempts made by scientists to classify the elements. The German scientist John Dobryner in early 1800s was the first to consider the idea of trend among the properties of elements. By 1829, he noted a similarity among the physical and chemical properties of several groups of these elements that are called triads. In each case, he noticed that the middle element of each of the triad has an atomic weight about halfway between the atomic weight of the other two elements. You can see in this table 3.1, the elements lithium, sodium and potassium. Sodium has an atomic mass which is an average of lithium and potassium. Like that, chlorine, calcium, strontium and barium with the atomic mass 40, 88 and 137. Chlorine, bromine and iodine with an atomic mass of 35.5, 80 and 127. In each of these cases, if you analyze, the atomic mass of the middle element is the average of the atomic mass of the other two elements. But this was applicable only for very few elements. So, Newland in 1865 profunded the law of octaves. He arranged the elements in the increasing order of their atomic weight and noted that every 8th element had properties similar to that of the first element. So you can see in table 3.2 downwards, lithium, sodium, potassium, and the elements are arranged, and 8th element repeated the property of the first element. But it was applicable only up to the element of calcium. So the need for classifying the element is continued. And Mendeleev, who was responsible for publishing the periodica for the first time, and it stated as follows: the properties of the elements are a periodic function of their atomic weight. Mendeleev arranged elements in horizontal rows and vertical columns of a table in order of their increasing atomic weight in such a way that the elements with similar properties occupied the same vertical column or group. Mendeleev's system of classifying elements was more elaborate than that of Luther Meyer. He fully recognized the significance of periodicity and used a broader range of physical and chemical properties to classify the elements. In particular, Mendeleev relied on the similarities in the empirical formula and properties of the compounds formed by the elements. He realized that some of the elements did not fit in with his scheme of classification if the order of the atomic weight was strictly followed. Keeping the primary aim of arranging the elements of similar properties in the same group, he proposed that some of the elements were still undiscovered and therefore left some gaps in the table. For example, both gallium and germanium were unknown at that time. Mendeleev published his table. So, he left the gap under aluminium and a gap under silicon and called these elements as Eka aluminium and Eka silicon. Mendeleev predicted not only the existence of gallium and germanium, but also described some of the general physical properties. In the beginning of the 20th century, witnessed profound development in theories about subatomic particles. So, in the year of 1913, the physicist Henry Moseley observed regularities in the characteristic X-ray spectra of the element. So, a plot of root mu, where mu is the frequency of X-rays emitted against atomic number, gave a straight line, and not the plot of root mu versus atomic mass. That is, when atomic number is plotted against the frequency, he was able to get a straight line. He thereby showed that the atomic number is a more fundamental property of an element than its atomic mass. Mendel's periodic law was therefore accordingly modified. This is known as the modern periodic law, which can be stated as the physical and chemical properties of elements are periodic function of their atomic number. Now let us see about the nomenclature of elements. Let us see about the nomenclature of element with atomic number greater than 100. The naming of the new elements has been traditionally the privilege of the discoverer, and the suggested name was ratified by the IUPAC. In recent years, this has led to some controversy. The new element with very high atomic numbers are so unstable that only minute quantities, sometimes only a few atoms of them are obtained. Their synthesis or characterization therefore require highly sophisticated, costly equipment and laboratory. Such work is carried out with competitive spirit only in some laboratories in the world. So the IUPAC has made recommendation that until a new element's discovery is proved and its name is officially recognized, a systematic nomenclature be derived directly from the atomic number of the element using the numerical root for 0 and numbers from 1 to 9. You can see in the table what is the digit, what is the name and the abbreviation. So 0 means it should be NIL, nil, N, represented as N. And for 1, it is UN, which is the symbol used as U. And for 2, it is Y, BI, and abbreviation as B. And for 3, tri. And for 4, quad, 5, pent, and 6, hex. For 7, it is sept. And for 8, it is oct. And for 9, it is N. So, the roots are put together in order to digit which make up the atomic number, and IUM is added at the end. For example, the element 101 is named as Unnil Unnium and the symbol is given as UNU. 102 Unnil Bayam, 103 Unnil Trium, and 104 Unnil Quadium. Like that, the elements are named. Thus, the new elements first gets a temporary name with a symbol consisting of 3 letters. Later, permanent name and symbol are given by a vote of IUPAC representative from each country. The permanent name might reflect the country or state of the country in which the element was discovered or pay tribute to noble scientists. So, let us see about the electronic configuration